We're starting about the planetary alignment tomorrow night. I bet it'll blow up on the news. This thing, and I'll be part of it. I'm invited to Digi now while I'm recording. I still don't know what I'll say on Digi, but I'll leave my recording from Digi here in the video. Alright, when I first heard that the planets are aligning, I thought they were already aligned. Just like in these images, and I guess everywhere you look you see these pictures with the planets lined up so nicely. Of course, my first thought was, man, there's no way something like that could happen, for the planets to line up so perfectly. That probably happens, I don't know, once every hundreds of millions of years, not during our lifetime, just every now and then. And I was right. Here you can see the actual positions of the planets as seen from above the solar system. Yes, from above the solar system. And you can see that the planets are not aligned as shown in those images. I'll put two images here as well. Let's start with the first Earth alignment. Here we see the Sun in the center, Mercury close to the Sun, then the planets Venus, Earth, and Mars. It seems that Earth, Venus, and Mercury are somewhat aligned. Earth align. I call this line 2. And Earth and Mars, actually, Mars is in a direction, so to speak, opposite to Venus. So the 4 planets are not aligned in a straight line. Now I'm going to put up a bigger picture, kind of a zoom out, and you can see the 2 directions again. Basically, when we look from Earth, somewhere in the center, yes. When we look from Earth in the direction of the planet Mercury, meaning in the direction of the Sun, because yes, Mercury is close to the Sun, we will see the planet Saturn in about the same direction, and the planet Neptune in about the same direction. That's what's called direction 2 in the picture. Then, however, if we look toward the planet Mars from Earth, yes, then we will see in the opposite direction, and in about the same direction, or approximately, are the planet Jupiter and the planet Uranus. Alright, let's look once more. They are aligned, but what's special is that they are all on about the same side of the Sun. Now, the interesting part is that I look at this image of alignment Earth 1 and I wonder what we should see in the sky, yes, when we look at the planets. So we have the 2 directions, 2 and 1. It's clear that in this position, on an evening day, yes, so we should be looking in the evening. At sunset, the Sun, that means direction 2. So if we're on Earth and we're looking in direction 2 at sunset, we'll see the Sun. And then, when it just sets, so right after it sets, we might still catch the planet Mercury in the sky. Yes, and in about the same direction we'll also see Venus. Now, however, if we look at the planet Mars, it's kind of in the opposite direction. So in other words, we should look more towards the east, and that's where we'll see the planet Mars. And if we move to the other image, the bigger one, we'll see in the same direction the planet Jupiter and Uranus, this being Earth alignment. 2. Alright, so when we look at the sky, what will we see? Let's look together. Now I also have that image in front of me, what I see on the right, where the planet Mercury is. The planet Mercury is close to the Sun. That's where the light comes from. You can see it a little, so in that area is the sunset. And the direction towards Mercury is direction 2 from my pictures. So, somehow, farther away, you should also be able to see the planet Saturn and the planet Neptune. And more or less in the same direction is also the planet Venus. And then, when we look to the other side, so kind of towards the sunset, so that would be the left side, we should see Mars. That would be direction 1 in my picture. And there, farther away, Jupiter and Uranus. Alright, so this picture is taken kind of with a zoom out. On the right we have the sunrise, on the left we have the sunset. The conclusion of the first part is that there is no alignment at all, sir. If you look at these planets, they're kind of in all directions, and if we look at the sky, we will indeed see them in the shape of an arc. So then, what's special from an astronomical point of view? There is something special, the fact that you can see them all in the sky at once. And this is visible because if we look at this big map of the planets, they're all in the same half of the solar system. And the fact that all the planets are positioned in a single half of the solar system. At some point when we're on planet Earth, which is spinning, we'll see them in the sky, and this thing is special. I read that it will happen again around 2040. So, from an astronomical point of view, it's something special. From an astrological point of view, it's a different story. Maybe I'll get into that later and talk about astrology too. Let's move to the second part, as I was also surprised by it. Why do the planets now appear as an arc in this picture? The first time I saw the picture, I said, hey, there's something wrong with this photo. Why? Because I knew that all the planets in the solar system orbit around the sun in the plane of the ecliptic. Yes, but if we are on planet Earth and we look at all the planets, they are all on the same plane. And so if I look in that direction, I should see all the planets in a line. But why does this picture show me an arc when they should all be in a line? Then I went on Stellarium. For those who don't know, Stellarium is a software that tells you where the planets and stars are positioned in the sky. I played around in Stellarium and noticed it there. If I adjust the viewing angle a bit, at some point you can see all these planets roughly in a line, just as they should be. But pay attention even here in Stellarium. I can change the viewing angle, and if I adjust it a bit, again you can see them in the shape of an arc. And then I looked at this photo again. Actually, I don't even know if it's a photo. I think it's an animation where you can see the planet Mercury at sunrise, and towards sunset, somewhere the planet Mars. We can imagine that Mars is right in the direction of sunset. Yes, and then, in this simple image that I had, I should have seen all the planets on the horizon, but it's not normal to see them all on the horizon. Because if I look at the simile disks, I should see one of the planets, let's say Venus. But since I'm at the equator, then I should see that planet right above my head. And actually, what is this picture here trying to say? Well, it's trying to say the following. Listen, folks, we can't take a picture of the sky as it is, which is spherical. Because if I go outside and actually look at the planets, I'll see Mercury at sunrise, I'll see Venus way up high somewhere, and at sunset I'll see Mars. So if I look at the sky, I'll see all the planets really nicely lined up in a row. But how can you project the sky onto a picture? It's clear that the star that's above should be at the top of the picture, and the star that's down to the right should be at the bottom of the picture. So normally on this picture we see here, I'll get an arc, right? Even though the picture shows us an arc. When you go outside and look at the stars, they'll be on a line. And actually that line will be the intersection between the ecliptic plane where the planets move and the celestial sphere, the dome of the sky. All right, where did the madness start? This? It basically started with astrology. Because in the old days, people believed that the planets and stars, especially the planets that move among the stars, directly influence our lives. And what was important for them was the moment when two planets in the sky came close to each other. So basically they had the same apparent position because back then it was believed that the power of those planets would be doubled. Even more so because they're right next to each other, let's say Saturn and Venus, they're close to each other, and then they influence our lives more strongly. And that's when the idea of alignment appeared, because we see them as if they apparently have the same position in the sky. But it's clear that one of them, now we know that one is closer, the other is farther away behind, so they would align from our perspective. That's when the idea of alignment appeared. It seems that things kind of exploded around the 70s when a book was published called The Jupiter Effect, which predicted what could happen. In 1982, when the planets would align again, it was said back then that yes, in 1982, the planets would align, and all sorts of problems would appear. Now let me tell you from the start. I checked for you to see how the planets would have aligned in 1982. Here you have the picture. You can see that it wasn't a perfect alignment. Not at all. It was just like today. All the planets essentially were in different directions, but they were in the same half of the solar system. And again, it was something not completely, it was something special for astronomers, but in no way were they so much aligned, but only for the better. Now I return to this book, yes, The Jupiter Effect in 1974, which took a few things into account. And one of the things it took into account is the gravitational force of the planets on Earth. Which in that book said, "Sir, does it matter? all the planets will pull on Earth in the same direction. And we know, for example, that the moon influences the Earth through tidal forces. So they said these planets can also influence the Earth, causing earthquakes, causing all sorts of unexpected things, right? I asked Chat Generative Pre-trained Transformer and I said, so make a calculation of these forces for me, and you can see it here. Let's say we have an apple weighing 1 kilogram, even though apples don't weigh that much. I said something silly. It doesn't matter. The calculation is done for a 1 kilogram object, yes? With AI, you can make pictures of good 1 kilogram apples. So we have a 1 kilogram object sitting on the surface of the Earth. It is attracted to the Earth with 9.8 newtons, yes, mass times gravity, and to the Sun with a force of about 10 to the minus 3 newtons. So that means millinewtons from the Moon, with a micronewton force from Jupiter, with a force of 10 to the minus 7 newtons. So that means about a few hundred nano, so a few hundred nanonewtons. Yeah, man. And when I looked at this thing, I said to myself, hey, that's just a little Christian pressura, but again, maybe you're making a mistake somewhere. Because if you look at the force with which the moon attracts, man, it's 10 to the minus 5 newton, it's small. But we know that the moon has tidal effects on the Earth, because we have ebb and flow, and I wrote about this in the physics book, the one I told you about. Yes, and if I look at Jupiter, well, it has a force that's only 100 times smaller, so it's not that small. It's 100 times smaller than the force with which the object is attracted by the moon. Yes, so the moon attracts that object with 10 to the minus 5 newtons, and Jupiter with 10 to the minus 7 newtons. Maybe this guy's right. That's what I thought at first, at the very beginning. But then I looked at it a bit more and realized there's another trick. Let me show you what the trick is. Well, that's not it, Christian Pressura, because you describe tidal forces in your book, The Story of Physics, and there you explained what these tidal forces are. They're the forces that the moon exerts on objects on Earth, right? Where you take into account the variation in distance between the object and the moon. For example, the water on the surface of the Earth. Yes, the water on the surface of the Earth is attracted by the moon. But we have, let's say, two positions where the water can be. The water can be on the side of the Earth that's close to the moon, or it can be on the side of the Earth that's far from the moon. If it's on the side close to the moon, then it will be attracted more strongly. Because the distance between the moon and the water is smaller than in the second case. When the water is on the opposite side, then the distance from the moon is greater, and the force of attraction is weaker. Yes, so this means that normally, because of these differences in gravitational force, the Earth attracts. No, excuse me, the moon pulls the water on Earth more strongly on its near side. And we should see how the water rises, how its level rises on the side closer to the moon. Okay, but the Earth also rotates around its own axis. And we also have centrifugal forces. And if we take them into account, we'll see that the result is the one in this figure. Yes, meaning on one side, actually on both sides, both on the side closer to the moon and on the opposite side. The sea level rises, and at 90-degree angles, the sea level drops. So on one side we'll have high tide, and on the other side we'll have low tide. What's important here is to keep in mind that, sir, the smaller forces are due to these differences. Yes, because of the distance. And then I said, just a moment. Let's see what the difference is in the case of the moon. If I take an object that weighs 1 kilogram, place it on the side facing the moon, and then on the side opposite the moon, I'm interested in what the difference is between the two. A 1 kilogram object placed on Earth's surface, both near and far from the moon. And you see here, the difference between the two forces is 10 to the minus 6 newtons. And this difference, yes, gives the large forces here. Now, however, let's go back to Jupiter, because this is where the trick is. Yes, well, Christy, just a moment. But Jupiter is much farther from the Earth. It's true that it's bigger. Because of this, it also gives a fairly large gravitational force, which is only 100 times smaller than the gravitational force given by the moon on the anticipated 1 kilogram object on Earth's surface. But that's what I wondered too. Well, wait a minute. Jupiter is very big, it has a strong force, but it's also very far away. And then the difference between the two forces, meaning you have an object on the surface of the Earth that's closer to Jupiter, and an object that's on the opposite side. Yes. So if we now calculate the difference between the two forces, as we see in this calculation, given by Jupiter, this difference should be smaller. Why? Because the distance to Jupiter is very, very large. So in other words, even though Jupiter is a big planet, the forces here will be very small because the distance is large, and so the difference between the two forces is small, right? This difference came out to 10 to the minus 11 newtons. Yes. So for the moon it was 10 to the minus 6 newtons. Here it is 10 to the minus 11 newtons. That is hundreds of thousands of times smaller. That means that if Jupiter had a tidal effect, then the level by which it would raise the water on Earth's surface, high tide, low tide, yes, it would be hundreds of thousands of times smaller than what actually happens. Which, as far as I know, is about 1 meter. So it's hundreds of thousands of times smaller than a meter. So indeed, it's very, very small. The conclusion from this video: if the weather is really nice, go outside and look at the planets now. You'll still be able to see the big planets, Jupiter and Saturn. And to be honest, they are very, very bright. You can't see Neptune or Uranus. Those can only be seen with telescopes. You will see Mars. Mars is also visible. In the next few days, it will look a bit more reddish. And by the way, there's a new article that shows the red color of the planet Mars might not be due to the dust. Like rust? Yes, from the surface of the planet Mars. You should read that one, and maybe I'll come back with that topic as well. Yes, okay, but what I want to say is that I've seen these big planets. You can see them in the evening, and they look very, very beautiful and very bright. And especially if you have a telescope, it's ideal to look at them, right? That was pretty much my second attempt at an improvised video. I'm not that satisfied, but I hope to improve this method. I will continue making videos on the usual topic and on this new thing, so to speak. With this free talking, I think I'll make quick reaction videos like this one. And finally, please check out my Patreon page, because I have something there that I see isn't taking off, but I would be happy if it could take off. Yeah. So you can ask me questions, and then I'll answer you directly on WhatsApp to those questions, either in audio or even video format. Of course, that's if you are Patreon contributors. I'm also thinking about the idea of taking some questions from Patreon and bringing them here in an open discussion. Why not? So, if you check the Patreon page, there's this possibility for me to answer you directly. Yes, on WhatsApp actually.